Zeblok improves the productivity for enterprise AI modelers and MLOps DevOps folks. With that, I welcome Mouli to the stage.
Thank you very much, Vrushabh. My gratitude to the Intel AI Analytics team for this opportunity to present here this morning. Hope you all are having a wonderful show. So this work that I'm going to talk about is representative of what we have been doing in the past, I would say, year or so. Working also with a marquee customer segment in financial institution, looking at the productivity and what constitutes real productivity improvements. How are the enterprise modelers really looking to advance and take advantage of all the features that Vrushabh just talked about. And so the talk is going to focus on the smarter AI journey, intelligent automation and routing for end-to-end pipeline optimizations. We believe this is a very interesting approach from a productivity perspective, the user experience. The focus of the talk is really the user experience, right? I'm not going to throw any metrics, any benchmarks. There are papers coming later on in the year, but really looking at an enterprise model. And if I have done my job well, then I would have communicated as an evangelist for an enterprise AI modeler, right? What their challenges are and all the wonderful tools that Vrushabh just talked about. How does that get absorbed and what are the barriers in adoption? So AI optimization as a service is our new feature that we are launching in the first quarter of 23. It's called as a service, but it's really a solution that is implemented within the enterprise environments and offers truly multi-cloud capability. Our inspiration here is really lowering the cost of AI journey, and workflows make that happen. Cost per insight is a KPI that we track, and we believe this is a key aspect for achieving that. So the focus is on persona, the persona of an enterprise modeler. Right? They want just a simple PyCharm environment or a developer environment, and they want to be able to interact with the system to accomplish the goal of the optimization. And we believe this can lower the cost function, the time function, by simultaneously executing these pipelines, the end-to-end pipelines in multiple environments like public cloud or on-premise environment on heterogeneous CPU, GPU, XPU architectures, and that's a massive benefit. I'll just take a couple of minutes to just talk about what the microcloud actually does as the next generation digital foundation for AI assets. And it does three things really well. It aggregates AI assets really well. It flexibly deploys these AI assets, and it has workflows for optimization of the models. So from an asset aggregation perspective, so what is an AI asset? It can be an algorithm, it could be the end-to-end pipeline Vrushabh was talking about, and workflows make it super easy for enterprises to create app store constructs, and whether it's NLP, computer vision, augmented analytics, explainable AI, time series analytics, they can all be ingested with very simple workflows and packaged them as APIs, as microservices, as workstations and pipelines, and it can be dynamically scheduled in different environments. The deployment flexibility is absolutely key. It's a full-featured ML ops platform from cloud to edge. Model training can happen in cloud environment or on-premise environments. Again, multi-cloud capability is very important. Core of what we do is focus on the SDK side, giving that whole experience for automation in the hands of the developers, right? So what are the challenges and what are the barriers, right? Meta scheduling is very important, right? To be able to take some of these containers and there's some of these capabilities that are cloud native, and to be able to schedule them simultaneously, because the regulatory and compliance environments dictate where the data resides for some of these model training activities. Composability is again a huge requirement from an enterprise perspective. It's one thing to have containers that have one DNN, one DAL optimized, TensorFlow, scikit-learn, PyTorch, right? But when the enterprise absorbs these capabilities, they need to integrate that further into their developer tool chains. And these developer tool chains require code scannings to happen. and many other layers of enterprise activity kicks into play. So there is a real barrier between a release of a container and its absorption at the enterprise level. So the dynamic composability of these containers, we believe, is super important. Plug and play of optimization engines is another very important area, but there are other optimization strategies with Optuner being an open source. RayTuner is another very popular approach for doing optimizations. The modelers are yearning for directives and primitives at an SDK level that drive this plug and play capability. Simultaneous deployment into cloud to edge, I've already addressed that, and then dynamic resource allocation. Modelers want to have control over not just, I want to schedule a pipeline. They want to be able to say, I want to, hey, schedule a pipeline. I want to take, left side to go to AWS, right side to Azure, or to the edge, or to in the enterprise development environment, and I want to allocate CPU, GPU, memory, and I want to up it down based on the needs of this training activity that is going on. Crossing server boundary, HPC, super important, and heterogeneous GPUs. So what would be a good visualization for this? Like, how can we talk about a productive workflow that covers all these things? I'm going to discuss that in the context of a BERT large model, and it uses, Hugging Face, it's, I believe, IMDb data set, moviegoers reviews, and it picks up the sentiment of positive or negative, right? And there are added on phrases for which this incremental training is being done, and transfer learning obviously helps it speed up. Obviously, that's one of the things that you just heard about. Things like Hugging Face help them. I want to talk about some of the other things. Basically, I want to anchor and reorient you, the audience, so that you know where exactly you are in the workflow. So there are workflows. Number one, bottom left side, we have workflows that basically constitute the microcloud itself, right? Whether it is an enterprise environment or thousands of edge nodes, infrastructure as a code capability that dynamically spins up these infrastructure components and deploys it into multi-cloud and bare metal environments. In environments where there is no Kubernetes as a service, we bring that. There are a lot of capabilities there. Once the microcloud is established, there are workflows for modelers, there are workflows for AI product teams within an enterprise. Think about shared services organizations that need to bring in the workflows, end-to-end pipeline starting point, curate them, and disseminate it efficiently within the organization and with external consulting companies or whoever is helping them, right? So that's number 3. 4 is, once the model is in, what are the workflows for optimizing? And then number 5 is, the model is now, you understand what a good inference engine is. Now you want to disseminate it, model serve it to edge locations or to bare metal within the enterprise or in public cloud environments based on policies. And 6 is, while it is running, looking at resource consumptions and looking at the data that's coming in, what's happening, what's succeeding, what's not succeeding, and going into this retraining cycle. Okay? But I want to talk specifically about one workflow, which is the optimization. So here we're talking about a very familiar interface for a Python modeler. Like I said, a persona is a person who's a sophisticated modeler. So in this case, there is a query made to the microcloud because it was already established. Hey, what all do I have access to? And it comes back with, hey, you have access to Intel Dev Cloud and AWS. And says, okay, now I want to submit my optimization job. And the primitives talks about the optimization intent, and again, over a period of time, intelligence builds into this layer. Here, the modeler also says, I need other kinds of libraries. It's pulled through as part of the workflow. Again, composability is very important. It dynamically composes the container that it then needs to schedule for running these optimization jobs. Now, the intent of the modeler here, the end-to-end pipeline in 2 environments and execute in AWS, Xeon, Cascade processors, and inside of Dev Cloud environment within Intel on, Ice Lake processors. So one of the things they do, go inside the microcloud and say, I want to collate the results of all these experiments that's going to happen in a multi-cloud environment. So the person goes in and selects ML flow as the tool for collating. Again, you can run the ML flow in AWS or Intel environment in this case. So they pick the Intel environment, set some parameters for the ML flow, and they start it up, and it runs now as a microservice. And all the things that you're seeing with the user interface here, by the way, is also available using Python SDK. So the same level of interaction can be achieved just on the, with the code. Now, once that is done, you've got a URL that is newly minted. The tool takes care of all the abstraction, service mesh architectures and all that stuff. And you take the URL and bring it into the SDK and say, this is where I want the results of the optimization coded. And then it fires up the job. And when this is started, it goes into the process of composing the containers. And this is where the software is seamlessly pulled in. Again, additional instructions can be passed along, in the scaffold structure on the code side to utilize neural compressors and utilize other, features that Vrushabh was talking about. So here now, it goes through the motion of, spitting out the container. And when the container is done, it interacts with the user by sending out an email message saying your container has been composed and it has been scheduled, right? And again, this is where enterprise tool sets become very important. The developer tool chains, it could be Artifactory, CI/CD pipelines, anything else they become part and parcel of how it has to be integrated within the environment. So it's fully integrable under those constructs. So now that the scheduling was done, you see that there were 2 runs started, and you can go see that the first one is the end-to-end pipeline that has been initiated in the AWS environment, and the second one has been initiated into the Intel Dev Cloud environment. There are logs and other such things that you can go access, and while these workloads are running, modelers can go or ops people can go and look at resource consumption, performance characteristics, identify where the resources have to be bumped up or not, and we are building the intelligence layer next on taking this feedback and passing it back into the system so it has auto-scale capabilities. So end-to-end from a modeling, model optimization perspective, we have abstracted it out. This experience carries forward, whether it is Xeon family processors or GPUs or potentially Habana or any other chip architectures we want to introduce. That is a super productive environment. Developers don't have to think about it, right? So now you've got 2 runs. You want to see the result. What was the best experiment, from AWS? What was the best experiment from the Intel Dev Cloud environment? And you can now compare and make additional decisions. And again, this meta scheduling extends out to other data centers. So I can simultaneously now execute in Azure, AWS, or on-premise environments. So that's a super productive environment for the dev modeler. For scaling enterprise AI, now from an edge AI perspective, deployment is a fundamental challenge. We operate significantly in this space. These are some of our partners that we are working with today. So we model serve the capability. So these inference engines, once trained, these can be packaged up and scheduled to execute on curbside data centers, smart kiosks, smart poles, things like that. And again, please talk to us. We are happy to discuss what your optimization challenges are. If you want a trial environment, we are happy to provide. We work closely with DevCloud. And there are pre-aggregated algorithms, the time series and other explainability and such. If you're interested, we can talk about it, but that's the end of my talk.